Alright, welcome. Welcome to the stream. I'm Agent Ultra, and tonight I'm just going to be coding on some stuff. It's pretty cold out there. Been snowing for days where I am, and it's finally let up a little bit. It's a bit chilly. So, grab a drink, something hot, maybe, and pull on up. Let's hang out, hack some stuff. So the project I've been working on for the past little while has been to try and implement something called a MUD, a multi-user dungeon. It's basically like a MMORPG, right? Except it's text-based, which means you type in commands and then you get updates from the game server based on what happened. Right? And it's real time too, and there can be multiple people connected concurrently. So, yeah, it's a bit of an old school kind of thing, but it's a great way. It's a great little project. Well, maybe not little project. It's growing in scope, but it's a great project to like just do some networked concurrent programming in Haskell. I'm experimenting with embedding scripting languages in Haskell applications like Lua in this case, and just having fun with it. So this week I'm going to continue on with what we were doing last week, which was trying to get the tokenized input string for the commands to get to the game engine code in Lua and pass it over to Lua. So let's get to it. So we go over to command. Okay. This token list type is the new one that we just added. Okay, there's these commands here, like special ones that the server knows about, but now we need to implement all of the other commands that the game designer is going to develop, right? And they're going to develop it in Lua, right? So that they don't have to do it in Haskell, and so that I can learn how to do stuff with scripting languages in Haskell, and because that's why. So we have to pass this token list, this list of text. This is like a tokenized string. That means like it's broken up by some separator, which is going to be spaces. And we pass in each little substring. And we got to build up a Lua table or array. But everything's tables in Lua. And so we got to convert this list into a table. Push it onto the stack. We got to do stack manipulation stuff and like actually call the user's parse function or handle function or whatever to handle the input from the user and do stuff with it. All right. So it's going to be fairly low level-ish, but we'll see what we can do to get that working. And yeah. Let's see, MUDCode. No, we're gonna put it. What was I putting out? Unprocessed commands. This is all the parsing stuff. Maybe we just put it on server. Handle token list, yeah. Alright. So this is gonna be the function that handles the tokenized strings. So we gotta do a bunch of stuff to get that to work. So I'm gonna bring up the documentation on Lua. On the Haskell side, the library we're using. I think we got to create a table with HS Lua set table. Takes a pointer. Okay, so we have to check that pointer for the status code to see if the set table worked. Stack index. I'm not sure what that argument is for. But I think we have to call this one to create the table. Oh no, or something to create the table, and that's like to set each thing on the stack to it. New state, no. Set functions. Table library. Oh, where was it? Not new meta table, almost. Good table. Create table. Okay, it doesn't look like there's an HS Lua create table. Okay, cool. So we got to call create a new empty table. It pushes it onto the stack. Parameter array is a hint for how many elements could be in it. We will know because it's a list. We know the length of lists. So we could do that. And then the parameter nrec is a hint for how many other elements the table will have. I'm not sure what that means. Lua may use these hints to pre-allocate memory for the table. This pre-allocation is useful for performance when you know in advance how many elements the table will have. Otherwise, you can use the function Lua new table. Maybe those will both be the length of our list. I think we prefix that with Lua. Let's just write it like that. Yeah, in order to lift IO that. And I probably want to get GHCID running. Boom. Cool. IOC type. Oh, we're missing an argument to create table. Oh, we gotta do the state, that's right. So we have to do this with the interpreter locked. That's what we created the lock interpreter stuff with interpreter, Lua interpreter lock, that's right. So we're gonna need to use that. That takes our callback function, and that's it. We get the Lua state. And it returns maybe a return value. call the callback in IO. Oh, because if we got nothing, right, then it would be like we didn't hit the log, we didn't execute your function. Okay, so hey, Twitch TD, what's up? Yeah, Lua is going to be the MUD scripting language. That's right. That's what I'm aiming for anyway. Let's see if I can get that to work. So far, this package is pretty good. I'm using this Lua package and learning quite a bit from it. By Albert Kruinkel, hslua.org. Yeah, it works pretty good. Oh, they got a nice little landing homepage for it too. Yeah. So hopefully we'll be able to build the game in Lua. The engine's going to just take care of kind of low-level stuff. And yeah. So I'm just doing some Haskell interrupt stuff here. We're trying to handle off. We want to hand off the tokenized input string from the user and hand it off to the Lua code for further parsing and handling. But to use this library to pass off like a list of texts that we get from tokenizing the input string, we have to create like a Lua data structure to pass it in as an argument, which requires us to like do some fairly low-level stack manipulations of the Lua's interpreter stack there. So, kind of interesting stuff to do, I guess. But that's what we're working on. So the end result, hopefully tonight, will be that we have some Lua code that gets this Lua table that we're trying to create as a parameter and then can do stuff with it. And then from there, I'm gonna see what I'm gonna kind of put on my game designer hat, my game developer hat, and go, okay, I'm writing my game in Lua, what kind of like API do I need to get things going from here, right? Once I can get this input from the server, this input from the user. My thinking has been like maybe this will be more where we'll start to see more things come together. Like we'll provide an API through Haskell, a bunch of Haskell functions to call things like into the ECS, the entity component system that will run all the mobs and stuff. Maybe some functions for templating and things like that. And then we might need some Lua callbacks from the game designer to handle events like when mobs move around and like stuff happens with the server simulation and stuff like that each tick. So we'll see how that all shakes out. Yeah, so let's create the table. The results. I'm going to ignore the result for now, just so we can work on the body here. Okay, and create table num tokens wants to be a cint, not just a Haskell int. So we'll just do a from integral. And use the num instance for that, or the whatever instance it is that from integral's on. Okay, so now we got a whole IO of A, so we got to return something here eventually. So we create the table, and now what do I gotta do? I gotta push those values into the table. I think it's set table. Stack index. Is it the only one I'm curious about the stack index pointer. We go to create table. Do I get passive? I don't get any return value back. So presumably that'll be at the top of the stack. Set table though. Let's read the code here. What is this doing? Oh, that's useful. It's just wrapping the C library. So I'm looking at the C documentation now just to see if I can figure out how that works. Well, there's a set field function. Do we have that on the Haskell side? No. Does not have set field in the library anyway. Oh, this is an auxiliary function that's defined. Never mind. Okay, push string, push number, then call set table -3. Set table. Gets all its operands from the stack. It receives the table index as an argument, pops the key and the value. The set field function assumes that before the call, the table's at the top of the stack. After pushing the index and the value, the table will be at index -3. Okay, so we can kind of create maybe a helper function like this. And we will push integers, push numbers as our keys. And our value will be the strings. Okay. Maybe we can do that in push token. We might need our int. X and V for value. And then we have HS, I think it's HS Lua push none. Number. Push string V. We might need a conversion of that text to something. And then we wanted to set table L -3. Now we need to call this several times, just for the effect. Sequence, maybe? All of this to give it the reader tokens. So get the function next, maybe like that. Not quite what I wanted. Ignore the results, yeah. Okay. No, traverse. That's probably what I want. Yeah. Okay, yeah, so we've got an IO action here, we've got a token in the scope. And so we can... Actually, I need the integers with them, so... We're gonna map these in pairs. We'll do... And I think most Lua programmers are like... The tables, when they're like arrays, they're one-based indices. So we'll zip those together, and then we can push token with the state and the index and the text, the token. They need to be prefixed. Lua. And then... No, you need it from the ersatz library, I guess. You don't re-export it. Oh, where does it come from? Lua to primary? Okay. Oh, it's just Lua at push number. Okay. Yep, there we go. Okay, so it does take int. It takes a Lua number. How do we create one of those? It's got a constructor. Okay, it takes doubles only. Okay, and we can't do text. We gotta do a C string. Okay, Do we want to allocate the C string here? I think Lua will copy it, and then I think Lua copies it if we push it on, right? So that should be fine. It's a bit wasteful, but it should be fine. So we can do with C string. Foreign.c.string. We will. C string takes strings. We'll have to pack that, unpack it. And pass from there. Now we need data.text imported. Okay, with C string, takes the string as our callback IOA. Yes. This is a weird type error. It's probably just something that I've values. Yeah, it's because I'm missing a do. Right, and we need a status code pointer. We need a pointer for the status code if we want to check it. So that comes from foreign pointer. We can just put a null pointer in, and then if we want to check it, do that. I might even put import a qualified pointer. Rendering is redundant. And some non-exhaustive command matches. That's good to know. All right, that's the error case. C string, does that return a type? Hey, yeah, IOA, I guess. Let's just ignore the connection ID for a second. Oops. Oh, push string has a return value. Interesting. IO of C string. Okay. Pushes the zero terminated string pointed to S on the stack. Lua makes or reuses, and yeah, Lua returns an internal copy of the string. So the memory can be freed immediately after the function returns. Returns a pointer to the internal copy of the string. We don't need that, so we can just ignore that. Okay, fields of server state stuff needs to be fixed. Interpreter lock is not initialized. Okay. I need a tvar for the lock state. It should be initially unlocked. Yeah. Unlocked. Pop that over there. Yeah, we compiled. Does it work though? That's the other question. Okay. Well, we're not fully there yet anyway. We're just back to compiling. So this is like a function that might do something. Maybe. Okay, so presumably if this works, then this pushes our tokens onto the table, into the table. So now the top of the stack is the table. The next thing we do is to call a function is push the function onto the stack that we want to call, I believe. Pcall. All right, to call a function, you must use the following protocol. First, the function called, well, we had to first put the function onto the top, onto the stack. Then the arguments to the function are pushed. Okay, and then finally we call Lua pcall. Okay, so how do I push the function onto the stack? We don't want to push an HS function, we want to call Lua function. I'm really in Lua load. Call. Is there an example? Lua get global L print. I guess get global puts on the stack. Okay. So we gotta, I think we gotta load the user's code. Hopefully their function will be in the globals. Then we can just do that. Get global L, name of their function. Da 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 da. What do we not call it? Parse? Handle? Handle command, handle. Yeah, handle command, we know. Get global. From the L state. Push that on the stack. Push the token, the table onto the stack. Push the tokens onto the table. Then call. I could probably do this all in one lift IO. And then the numargs is 1. Number results. I don't think... Do we need results? I think we probably will. Like... We probably just want to know that the user's code ran and that everything was fine. Or if they had troubles running because of something. I'm going to put number result 0 for now. Stack index is 0. Results. Stack index. Oh, probably needs the state. We want get global instead. And we don't have enough arguments to just look at global. Let's takes an additional status code pointer is returned. Call states T string. It also takes a C size. I guess the size of the string. Okay. Pointer to status code. Okay. So we need with C string what is it? C string len. C string len. I've probably complained about it several times in these streams. So annoying. Null pointer here as well. And this is exactly why. It should just be the size of, not an integer. Well, there you go. Okay, so if we run the server and we hit this code, we're probably not going to work yet. Maybe, and I gotta double check this, is because we have to load the user's code. I want to double check, make sure we're still doing that, because I've been messing around with it a lot. That's Lua with interpreter lock, server. No. So we have MUDCode, which calls load main, reads this file on the main code path main.lua. Okay. And I think I set that up to be in Bakamud main.lua here. So handle command should take our table let's just print it out. Let's see what happens. Let's run the server. Okay. Actually, get the client up. Let's connect to it. Got a connection. Oh, we got disconnected. Segfault, awesome. Yeah. Okay, so we probably got into that code. We're getting a segfault, which means we're trying to somebody's trying to access memory that's probably it's trying to access memory that's no longer there or it doesn't belong to them. Maybe it's actually getting something to handle command, but it's probably just before there when we're setting up the table. Pushing tokens and so forth. and such and whatnot. So we're going to do a little bit of debugging here. See how we get on. That status code pointer, we could probably check that every time we go to push on it. To access a pointer, to dereference a pointer, we have to, I think we just use peek from foreign.storable. It's going to be null, though, because we give the null pointer. We have to give the A type of what we're trying to peek when we go to get that pointer. And I think let's HS Lua's. We're looking at set table. Status code. Basically a cint. Okay. Wrapper around a cint anyway. Okay, so we should be able to peek at the status code. We'll use a type application to set A there. Yeah, I think this will be fine. Does GHCID agree with me? Oh, it's a Lua status code. Yep. Yeah, I gotta bring debug.trace in. Scope. Okay, makes sense. Okay, still got the segfault, but maybe even before that part. Let's start up here. Not too worried about that. Bind it to get global results. I'll try and print that out. we get that far before we get to segfault type code. What is that? It's probably, there's probably a function to interpret what that is. Type code. Okay, it's like a pattern. Type pattern. Yeah, 0 is t nil. Okay, nil, nil. Okay, so that means, I guess that means it couldn't. Handle command is nil, so there is no global called handle command. I guess that's probably what that means. I want to make sure that we're actually calling load main. Okay, we do call load main. Call read file. Okay, this just gets the contents of the file. In simulation, we call load main. Ah, okay. That makes sense. So we still have some of the prototype function code that we in here where we were doing stuff with trying to push Haskell functions onto stack and such. Okay, so let us, I want to create a commit before I do this. Okay, so we do, I think we should check that the handle command function actually exists, which is what this would help us do. And clean a little, just a little bit of this, commit it, and then we'll do that refactor to move the main code loading further up, and then hopefully see this actually run. Okay. So do a case match on handle command results. Haskell wouldn't. There we go. Lock up on me there. Okay, so then our type patterns are Lua nil. We want Lua T function. No parameter. Yeah. And if it is, we go here. Otherwise, we error. Let's just throw an IO error for now. Netbind handle command user function. Yeah, we should probably do similar things, I guess, with the status code and whatnot, but hopefully this will be good enough for now. So we'll commit this as in a working state here. Okay, the next part. Okay, we want to load the main MUD module, I guess, up. Yeah, closer to where the server started. It's kind of like top level server stuff. No. Network server, that's the low level part. Or lower level. Maybe here when we start up. And then we'll replace this with our Lua interpreter lock stuff. Might get a circular import error with that, but maybe we're fine. Okay. load the buffer, I think, is what we do, right? We initialize, yeah, we probably need to initialize the open libs. We need to import Lua for that. And okay, so we got to convert it to a C string. We get a result from loading the buffer. And we can free and do the result and check everything went loaded okay, I guess. It's the thing there. All right. And we need name, I guess, because we got to give it a name. I don't know, name. We'll return that result. Load code result. Yeah, I'll pull it out after. Okie dokie, so yeah. C string, let's go. With C string, with C string len, I think. A new C string len, sorry. Cool. Down over here. Stato. The size. Foreign Aceta types. Okay, then we read the code pointer, return the Lua result. Oh. That's it. Marshall Alloc. With a 1L. Okay, so we get a load code result, and then we can check that, and if we can't load the user's code because something's wrong, then we can just error out here and not start the server. What are we matching on, though? Maybe Lua status code. Okay, let's check that. It's just an integer. We just get an integer. There's got to be a way for us to know what that status code means, right? I mean, it's got to show instance. Status code. Oh, it's got type patterns again. Okay. So Lua OK is good. Okay, so we could return like slightly different, more helpful error messages here, depending on the result we get. So we get nothing is interesting. I'm not really sure what we get there, but if we get just Lua OK. We only care if it. We only want to error out if it's not Lua OK. So maybe we should use a when. So when the load code result does not equal just Lua OK. Okay, let's see if this works. Okay, well, we didn't get our segfault. That's a good start. We got handle tokenless start. We got to there. But doesn't look like our Lua code printed anything out. did our p call maybe not work? Well, let's commit this. Oh no, we're not quite done with this change. I need to remove the old code out of simulation. I want to keep that somewhere just because I want to remember how to do that. I think we can just get rid of all of that code. LT var. Still need some of that. I think we're going to get rid of that out of the simulation state, though. Okay. Just do a quick run. Reconnected server. Hey, System Carl, what's up? You're having trouble viewing the stream on your computer. Oh, that's unfortunate. But it works on your phone, so that's good. Not sure what would be going on there, though. Although, I don't know. Who knows? Maybe Twitch is having issues. Okay, so nothing breaks yet. Still not getting that printout, but we're not getting the segfault anymore, so that's prog. So we'll quit the server. We'll push this up, or we'll make a commit for this. Load. It's just my stream at number 1000 error. Huh. I don't know what that means. What is it? Twitch. Browser problem, maybe AI says that anyway. Maybe it was something, browser cache issue or something? Ad blocker, maybe? Something like that. Okay, so that loads the code up there. Now we can get back to working on handling the command and checking that everything worked. Okay, so we don't get to here, clearly. trace in here. Reconnect to the server. Just to start. This could be that if we get to this branch and error, are we just killing the thread and not giving over to not flushing the output? Maybe miracle. It doesn't seem like that would be a thing, but we're not getting to there. Let's see if we can print out the handle command result. Reconnect. Let's see. See if we even get that far. What's this warning? Oh, there's a result from the Lua MUDCode that we're not ignoring. Or that we're unintentionally, potentially unintentionally ignoring. Okay, that might be useful. Pop that there. File and run. We just get to start, nothing else. What is happening? We don't even get to the interpreter lock line? That shouldn't be right. We aren't checking the value of it, so that could be a thing. It might be that we're failing to acquire the lock because I messed something up. Oh, look at that. Oh no, it's somebody called with interpreter lock. Right, we do at the beginning. We do call it again here. So I guess we do give it up. And take it again. We're going to need a show instance on A. Yep. System Carl suggests maybe an encoder mismatch. Yeah, definitely could be. Okay, we get a return value status code 0 from our callback at the beginning. I think that's expected for that one. Okay, we get nothing. So we might not even be getting the interpreter lock when we get to that part, potentially. This might be a bad design. Or good design, and I'm just not using it right. Okay. Results. Show the results. Nothing. And if it worked, we should have gotten just status code, or just A, whatever A is. We get nothing, that means we're not getting the lock. So this, we get this once. Oh, we have to unlock the interpreter. There it is. And that needs the state. There we go. Okay, so that's a fix that I like. I think our commit is going to be a little bit uggo. That's okay. It's okay. Don't worry about it. Don't worry about if it's ugly. Your code and your own personal projects and your side projects can be as ugly as necessary. And I find that even when you're programming, especially when you're programming Haskell, maybe more so than other languages I've used, Ugly code in Haskell isn't so bad because it's very refactorable due to the type system. I can't say the same for like really ugly C code, for example, which I like writing C code. I write a lot of it. Well, maybe not a lot of it, but like I write a fair amount of it, or C++ code. Like, but ugly C and C++ code can get real nasty. You have the opposite. It always has to be clean every single line. Yeah. I mean, at work it's different, right? Like if I'm writing code because somebody's paying me, obviously I'm going to do the best that I possibly can. And if I have ugly code, it's just going to be a temporary state. Like it's going to be a work in progress commit. And then before I even push it to the server, I'll probably do a refactoring step and clean it up, so that people reviewing it don't have to review my nastiness. But sometimes when it's personal code, I'm like, meh, life's too short. Okay. So we unlock the interpreter, that's good. We get the type code then when we go to the handle the token list. Type code 0 is probably nil, right? Non-valid stack index, Lua T none. That's a -1. Yeah, nil is 0. Is that right then? I'm not super sure what we need to be checking here on the result of P call. To be honest. All right, we check T function here. So we're not getting... We're just getting to here. And then when we pattern match on the command result itself, we should be jumping down to here. Pop that bad boy in there. The system calls code is always art. That's great. Okay, so we are getting to that branch there. We're getting to the... And we're erroring out and probably killing the thread with our error call. Maybe the output is just getting swallowed by the main process thread, so it's not getting outputted there. But that's definitely one thing I want to fix with this. We do all these forks, but they're not handling the exceptions on the child threads that they fork from, so they shouldn't need to be doing that. Yeah. Okay, so we're getting a nil. Is nil the right result? Maybe nil is the right result. What should happen, Lua, if when I call pcall a function that I've set up on the stack and it returns properly? Calling Lua functions. then you pop the results from the stack. So this function should only, well, at least for now, should only have a side effect. So I don't think it'll leave anything on the stack. Push your function an argument. So you push your function. I guess get global does push function that global onto the stack. Okay. Push the number, push the second argument. So Lua pcall itself. I assume our Haskell library code is probably covering all that up. And then we can check on the stack if it's not a number using this isNumber function, looks like. And we get the value. Okay. If there any error while running, it returns a value different from 0. Pushes the error message on the stack, still pops the function. So the result of pcall should be a value on the index. Okay, so nil, I guess, is expected then. It's not pushing a function on the stack as a return. How is pcall on the Haskell side of things doing its business? Just literally calling the C function and returning the status code for it. Okay. Okay, so it should be getting there. Everything was fine. So the handle command result, I think, maybe is just a little bit of a red herring here. Oh, no. No, the handle command result, yeah, we get the global. Okay. Okay, yeah, sorry. I was looking at the wrong thing. Global gives the type code. So that shouldn't be nil. That should be a Lua T function type code. We're getting the nil type code. Okay. So, when I call load code, with the load code result, if it's not okay, it should error out the server. Let's run it. Just stays code 0. I think that means Lua. Okay. Yep. So the load happens fine. Load buffer. Maybe it's not. Manipulating, like changing the interpreter state. Loads of buffers a Lua chunk. Same thing as Lua load buffer. Like maybe it's loading the chunk, but it's not, like I have to manually set the globals something or something, or like extract things. Or maybe it's not a global. That's all stack mutilation stuff. Top pointer, teaser data, rolling. Pushing strings, pushing stuff on the stack, no. No, don't want to get metadata tables. Okay. Oh, okay. So Lua load loads a Lua chunk without running it. If there are no errors, Lua load pushes the compiled chunk as a Lua function on top of the stack. Otherwise, it pushes an error message. Okay, so load buffer loads a buffer as a Lua chunk. So it loads the chunk as if it was a function, which I guess is why it needs a name argument. I was kind of confused about it. I'm like, why does it need a name? And I guess that's why. So I am assuming when I'm running this code here is like loading the code in the buffer and like, you know, if it's got things defined in the module, like this function here, that will become a global name in the Lua interpreter state. Right, this message would be also like a global value. This would probably be bad. But what it sounds like what's happening is that when we do this, it's loading this as if it's a function and putting it right on the top of the stack. So how the F do we either get this where I can have these functions defined in a module, I can call the individual functions, or if I have to treat a whole file as a single function, how do I get the arguments? That's how Lua load works. Wow. It's the require stuff. Using the module's, the interpreter's own require functionality to load code. Well, I'm gonna have to figure this out, but I made a bit of progress this week. So that's going to be the next thing to try and figure out is how do we load a module of Lua code with a bunch of functions in it and call one of them. This is interesting, right? So with cstring, get global, right? Print, I guess, is going to be a global name in the interpreter's environment, right after you call openlibs, as is version. Numargs one argument pushed on the stack, and then the function is the next thing on the stack. Num results 1. Stack index is 0. Actually, we don't even get it. We get nil when we go to look that up. That global. So there's no function, there's no global named handle command basically in the interpreter's environment. Even after we call that load code stuff. Okay. Alright, well, that's all the time I got for this week. So we're going to have to kind of leave the code in this kind of debuggy state, I guess. And we'll get back to it next time. Work in progress. Loading Lua code. Okay. I'll push this code up. Why not? We'll just reword things a little bit. Let's leave it as a work in progress commit though, just so y'all know that's like kind of broken right now. So changed. We refactor the load main module code. We added an implementation for handle token list. So we're trying to work in progress, trying to load the user code, a module of user code, call a particular function, and pass it the token list. It's an argument. Still need to figure out how to load the module of functions, Lua functions. Okay, so all the code you've seen tonight is up on GitHub. I'm Agent Ultra, and Agent Ultra on GitHub /Bakamud. Paste y'all the link. Boom. Thanks for hanging out with me tonight, and you know, coding along and following along through this, at least where I am, cold, snowy weather. Which is nice, because I like to huddle up in my little cave and keep toasty and hack away on little recreational programming projects for funsies. This is a mud server that we're working on, Bakamud. So check it out, like, star, whatever. All good. You can also follow me on types.pl. I'm on Mastodon and the Fediverse there, so types.pl, Agent Ultra there as well. And I do these streams regularly on Tuesdays at about 10 after 8 in the Eastern time zone. So if you want to follow here on Twitch, you'll get and set up your notifications. You'll get notified when I go online and stream, or like, subscribe, and leave a comment and all that stuff on YouTube and feed the algorithms. And you'll get notified when I post a new video where I back up the VODs for these streams on YouTube as well. So that's all good. Or you can just write it down and show up, you know, whatever. However you do it, you do you. Let's see. Check out the link above my head. It's declarative.tv, little website. There's a lot of other streamers listed on it that also do streams in languages like Haskell, but also Erlang and Elixir and Gleam and probably other things as well. All looking for an audience, and if you are looking for more streamers to follow, check it out there. There's also a link to a Discord server on that webpage where there's a channel for this stream. So if there's a question you have, you just want to hang out, chat, join the channel, join the server, join the channel, all that sort of stuff, and ask away. And that's all I got for you folks. So thanks again for watching and tuning in. May all your monads be free and your types always check. And happy hacking out there. Stay warm, stay safe. We'll see you next week.